Welcome back to The Explainer. So today we're tackling something that's going to completely reframe how you think about artificial intelligence. You know Christopher Nolan's movie Memento, right? The main character, Leonard, is incredibly resourceful in the moment, but he literally cannot form new memories. Every time he goes to sleep, his mind completely wipes clean. He has to navigate his entire reality using just Polaroids and tattoos. Well, according to futurist Thorsten Meyer, that exact scenario is the reality for every single frontier AI system operating in the world today. We're calling this the Memento Constraint. Okay, let's dive into this. Just like Leonard relies completely on those external notes and tattoos just to make it from one scene to the next, today's top-tier frontier models, we're talking Claude, GPT-5, they require this elaborate external scaffolding. I mean, don't get me wrong, they're undeniably brilliant within the confines of a single conversation. But if you want them to actually remember your company's preferences, your code base, or even just what you chatted about yesterday, they need external crutches. Things like RAG, retrieval augmented generation, and complex vector databases. They aren't actually learning anything new. They're basically just constantly referencing their own version of Polaroids just to hold a coherent conversation with you. Section 1. The AI amnesia problem. So this all boils down to one absolutely crucial engineering constraint: the training deployment boundary. See, during the training phase, a model is like a giant sponge. It's compressing vast amounts of data into its neural weights. It is actually learning. But the very second that model is deployed for you and me to use, it freezes. It crosses a hard, impenetrable boundary. From that second forward, it only retrieves and reasons. Once your conversation ends, from the model's perspective, it literally never happened. Every single interaction starts completely fresh from those frozen base weights. Section 2. The multi-billion-dollar tax. Now, what's really interesting about this slide is that staggering number right there, $50 to $150 billion. That is the estimated annual global enterprise spend happening right now. And get this, what is that money actually buying? It's not buying more advanced AI reasoning, no, it's buying workarounds. This is the global cost of just building and maintaining substitute memory layers. All those vector databases, the orchestration logic, the compute power for embeddings, it's all just a massively expensive band-aid to compensate for AI amnesia. Let's break that down into practical terms. For your typical Fortune 500 company running, just a handful of AI workflows, that penalty comes out to roughly $3 to $8 million every single year. You've got forward deployed engineers spending massive chunks of their time just wiring these static systems into tools like Salesforce and GitHub. Why? Specifically because the models cannot retain what they're told. You tell an AI a rule on Monday, and you literally have to pay infrastructure costs to store that rule and refeed it to the AI on Tuesday. It's just a massive, completely hidden tax. Section 3. Why context windows fail. So a really obvious question comes up here, right? Why not just make the context window bigger? I mean, if the AI forgets, just give it way more space to read all the past context at once. It's kind of like cramming for a huge exam 5 minutes before the bell rings. And we've absolutely seen labs try this, pushing from 1 million all the way up to 10 million token context windows. Honestly, it's the tech industry's favorite brute force workaround to entirely avoid the much harder problem of actual persistent learning. But as researchers Malika Abakirova and Matt Bornstein so brilliantly put it, I love this quote: "The filing cabinet keeps getting bigger, but a bigger filing cabinet is still a filing cabinet," right? Simply expanding the storage space does not magically give an amnesiac the ability to synthesize information and actually compound intelligence over time. It just gives them way more paperwork to read through before they can answer a single question for you. And this brilliantly illustrates why that brute force method completely breaks down in practice in 3 main ways. First up, effective versus nominal context. Look, just because an AI has this space to hold 1 million tokens doesn't mean it actually pays attention to all of them. It suffers from this lost in the middle effect, where it just drops details. Second is agentic loop pressure. As these complex, autonomous agents take hundreds of steps to solve a problem, their context window fills up with state data, and they literally just run out of working memory. And finally, cross-conversation persistence. Even if you had an infinite context window, the system still hard resets every Monday morning. It has to reread and relearn your entire business from scratch every single time. Section 4. The invisible capability race. Okay, so behind closed doors, all the major AI labs are quietly racing to solve actual Layer 1 continual learning. But actually letting a model update its core weights out in the wild, that is terrifyingly difficult, and it's mainly due to two massive roadblocks. First, you have catastrophic forgetting. If an AI updates its neural weights to learn a new legal document today, the underlying math might completely overwrite the medical knowledge it learned yesterday. It's literally overwriting its own brain. And the second roadblock is alignment drift. If a model is continuously learning from users pushing boundaries out in the real world, its safety guardrails will erode over time. It'll slowly drift right into dangerous, jailbroken territory. So, to conquer these genuinely scary hurdles, researchers are currently experimenting with some incredibly fascinating cutting-edge methods. They're testing out things like elastic weight consolidation, which basically penalizes the model for changing weights that are tied to past knowledge. They're also exploring modular architectures, replay buffers that constantly remind the model of past data to keep it fresh, and even test-time training. But the ultimate challenge here? Getting any of these methods to work flawlessly at scale, all while keeping the model safe and auditable for highly regulated industries. So who's actually going to get there first? Well, the speculative probability of who wins this massive race is incredibly tight right now. Anthropic is sitting at about 25%, wielding a really deep edge in safety, which, as we just talked about, is absolutely crucial for preventing that alignment drift. OpenAI is also right there, at 25%, leveraging their massive research budget and super aggressive product velocity. Right on their heels is Google DeepMind at 20%, bringing literally decades of foundational research to the table. And then you have Chinese labs at 15%, with Meta and a few others rounding out the field. Guys, it is an absolute dead heat for what will be the most important breakthrough in modern computing. Section 5. The Memento Singularity. Let's move to and see how this builds into what happens the exact moment one of those labs achieves a structural compounding lead. The timeline here is wildly aggressive. When a lab finally announces true continual learning, within just 60 days, chief information officers globally are going to be forced to make a hard choice: migrate immediately or be left in the dust using an amnesic AI. Fast forward to 12 months, and we'll see massive market share consolidation. And by 24 months, even if the other labs manage to catch up, it doesn't matter. That first mover advantage is totally locked in, because the winner will have already captured years of real-world compounding customer knowledge. So what's the actionable reality for enterprise leaders today? How do you prepare? First principle: treat your current memory layers, all those incredibly expensive vector databases we talked about, as purely transitional infrastructure. Do not get locked into 5-year contracts right now. Principle 2: capture validated experience today. Start building a corpus of how your company actually makes decisions, so that when continual learning does ship, your AI basically has a textbook ready to immediately absorb. And principle 3: maintain vendor optionality. If you get deeply locked into just one vendor and they end up losing this race, you're going to pay an enormous penalty. So, the crucial point is this ultimate paradigm shift. Currently, an AI's competence is strictly determined by how much compute power was pumped into it during its initial training in the lab. It's static. But the very moment this memento singularity occurs, AI competence entirely stops being a function of training compute. Instead, it becomes a function of compounding deployment time. Let that sink in. An AI that has been working alongside your specific team for 3 years will literally be 3 years smarter and vastly more adapted to your business than any brand new model fresh out of the box. I want to leave you with one final, truly provocative thought to end this explainer. As we finally move away from these amnesic models, we really have to ask ourselves, is AI going to remain simply a static tool that we operate, completely bounded by whatever we prompt it with? Or are we truly ready to manage dynamic systems that actually compound their own competence day after day after day? This race is largely invisible right now, but make no mistake, the lab that solves this constraint is going to completely rewrite the trillion-dollar enterprise economy. The real question is, will you be ready when they do? Thank you so much for joining me today. Keep learning, keep questioning, and I'll catch you in the next explainer.